Hello and welcome everyone. Today we will see some of the Lissajous profiles using LabVIEW. And for that purpose, we will make a program in which we will change frequency, phase, and amplitude of sine waves to see the different shapes and try to make different shapes, such profiles using LabVIEW. So for that purpose, first we select express XY graph, which we can change its properties so that it would look nice. Thus we will go to scales and select the simple ones, and similarly for y-axis select it, and then we can just change its color like from the tools palette. Let's just say I will select the white one, and then again if I go to properties, now I want to select the line should be dark enough to see properly, and then the line color will be blue in my case. So that's how it is, and these axes will automatically set themselves, so I will let them keep that. I'll change, let's say just graph, I will change its name, and then I will shift to block diagram to start making a program for it. This first we start using loop, and then now we want to make a program to change the frequency. For that purpose I will start from using this dial. The frequency I will maximum go to 50, select it, and this dial will be our frequency. And I will also show its digital display, which I will show below, and I will change its representation, although we don't need to change, but still I will change the representation because we will have to select only numbers, not in fractional form, just double precision dBl form, not dBl form, sorry, in long 32 integer form. And this is the frequency for the setup 2, and we can change its colors as well, like in this case needle color will be red so that it will show me. And similarly I can create align them, and now I can replace their name with phase difference, phase, and this will be our phase 2. Now that looks better. Now I want to include one more term, which is our amplitude basically. So I will add here and align them, make their horizontal centers equal, and similarly if I go here, drag it here, now the phase, instead of phase we are now dealing with amplitude, so change its name, and similarly amplitude 2. Again we can make it a line, and horizontal centers should be equal so that it looks proper and nice. We can make our grass a little bit larger so that it will be more clear visible. Now we jump onto the block diagram, and we have the phase, frequency and amplitude here. I'll begin with the frequency. I want to multiply it with 2 pi, which I will do from here, and then I will multiply it. I have to make the points. Basically it will draw points, it will draw the profile. For that purpose I have to select the number of points through which it should draw. For that purpose I divide the iterations like here. I'll divide it by 100 right now, and then I will multiply it. I will just make a copy of it and multiply it with this one, and then I want to change the phase. Basically for that purpose I have to add the difference of phase. That will be my phase. So here I will change the phase. Now I want to implement some sine wave. So searching for the sine, not express, trigonometric. Yes, I want it. So this is for our first. Now I want to implement the amplitude change as well. If I want to change the amplitude, let's just multiply it, and there you have it. Now it's ready. We have the frequency, we have the phase, we have the amplitude, and this is the number of in which the profile will be. This will be the steps basically in which the profile will be generated. And now similarly I have to do the same thing with my phase 2 basically. So let's just start making it. I will do this by doing again multiplying it with the frequency 2 pi, multiply with frequency 2, and then again multiply it with this one, and now I have to implement the phase change, for which I will add the phase difference. And then in the end, now you can select either cos or sine, but I will go with sine because we are implementing a phase change which gives a pretty much idea that it will be converted to cos, like when we have a proper phase change. So after multiplying it with this, now we are ready to have it, but we cannot directly attach it with x and y inputs right now because it will just move in the loop and it will show nothing. So for that purpose I have to go to build array form, which will allow me to have it in recurring form. So I will attach it with here, and I will attach it with there with the loop and replace with the shift register. Now what will the shift register do is whatever values will appear here, it will go in the loop and comes back from this position, so that every next value will be added to our next loop, but sorry, I cannot make it like this. I have to go with like this way, like this, so that my each value will appear here. It goes in the loop and comes back from the shift register and comes from our left side, so that it will be our next value, and it will be stored like in this form of array, so that it will form an array. Similar thing we'll do with our next function, and we will add a shift register as well, and we will attach it with here. Now every time I will run this will store the values, and the last values will be shown, will pass through it. But I don't want to, every time I run the VI, I don't want to save those. I will want to reset that profile. So for that purpose I will create a constant and attach it with this one as well, so that both of the profiles or both of the functions should start from 0 whenever I reset the profile. It means whenever I hit run button on LabVIEW. So now we can attach it with this one. So here is I will connect it with the x1. It doesn't matter where you connect it, I will just connect it at the y1. Now still we are getting an error, which will most probably be because yes, we haven't created the control condition to stop it, the loop. Now I will create a wait for 100 milliseconds to create the profile. Now we will go on our front panel and see if it works properly or not. Let's just try making some profiles. For the profiles, I want to create first a circle ones, which looks more simpler, and for that purpose you have to search the frequencies and the phase difference. This is the main purpose of all the Lissajous profiles. So for frequency and phase difference is very important. So for frequency, I will say I will keep the frequency 20, and the frequency of here is 20 as well, and the phase difference in here should be like 33. So I will put the phase difference of 33, and right now my amplitude is 1 and 1 here as well. It maximum should be 10 as well. So now if I try and hit run button, I can see that the points in which it made is right now it shows me some polygon, but the problem is here is with this number most probably, because we are getting so much less points. So I will increase this number by 1000. Now I try and hit run button. Yes, we are getting now more points. With this much frequency you have to increase the points. And what happens if I lower the numbers as well as lower the frequency? Now see what happens. Now again you see, either you have to deal with the frequency or either you have to increase the numbers. So I will go with the frequency and I will change the numbers here. I will add 1000, so that now we want to have another profile. This is our circle ones, and now I want to make a profile like this one, the A form. For A form I found that let's say my phase difference will be 60 degrees, and The frequency ones is 10 and 20, so it will be 10 ratio 20. Now let's just run it and find out if it makes properly or not. It makes a profile, but I found out that this profile is similar to B. We have to change its face to upward position. So let's just say if I make it 20 and make this one 10, now I hit run button. Let's say what it happens. Now the profile right now changes to from top to bottom. So what happens if I go change this one and keep it 0, this one? Still there is no change. So I will try doing this thing. I will change the phase basically. So to change the phase, I go to -60, so it means it will go in the fourth quadrant, and now the profile for that is perfect. Now we have gained a perfect profile for that because we have changed the phase. Basically we have gone to fourth phase so that it will be shifted to our upward position. Now we will try making another profile which will be our D1, and for that purpose we will go and stop the program and we will select some phase difference of, we say right now I say 50, and the frequency ratio will be our 30 and 40. So now if I try hit run button, let's see if it makes or not. It tried making the profile, but it is not much in better form. So I will try to increase its phase difference, and then let's see if the profile is in good position or not. Let's just say 66 degrees. No, the gap is just more increased rather than being decreased. We have found another profile. So you have to calculate basically the phase difference for this one so that it will properly execute. Still we are getting not the proper one, so we will play a little more with the frequencies so that we can see. Yes, now we are getting closer to our goal. Now let's say I go to 53 and now I try hit run button. It will most probably be giving me the right ones. No, it changes the phase right now, so we wanted the upward position. So let's just try this. Try making it the phase of the upward phase is 40 and the downward phase is 10, and now I try hit run button. Let's say it is close but still not good yet. We will change its frequencies so that it will change its position. And now if I see, now it is much closer to this profile. It is almost equal, but it has a little phase difference right now, which you can most probably remove. Now I will go to next phase, which is our F1, and for the F phase we have to make the phase difference of, we'll go up here and change the phase difference. So for this purpose I will change the frequency ratio of 20/30, and then the phase difference of 0 and 160. And then if I see, that's how my profile is being generated, which is quite simple, quite similar with this one. So this is this profile. You have noticed that we have not changed the amplitude yet, so we will try changing its amplitude. Right now it is 1 cross 1, so if we change its amplitude right now, you can observe that its amplitude goes to from 10. So what if I make it 1 and the other one 10? Still the profile is same, but as you can see that on x-axis it is 10, amplitude of 10, but on y-axis it is the amplitude of 1. So this is the difference of amplitude. Now we will see our G profile. For the G1 I will go with the frequencies of, yes, 30/20 will be good, and for the angle we will set the angle of say 120 right now. There is a little phase difference still right here, which is not good. We want to make it proper, so for that purpose I will go with the phase difference of 122. I hope this will work fine. Yes, that's quite good. Right now, as you can see, this is our zip profile and it is good. Now we want to make the last profile. For the E1 we will go with the frequencies of, we will make this frequency 30 and this one 40, and our phase difference should be 0. Now if I try hit run button, let's see if our profile is being generated or not. As you can see, our profile is being generated, which is very similar to this one. So that's how you can make the Lissajous profiles using LabVIEW. I hope you will like my video and my work. Thanks.